Pythagorean theorem. C squared is equal to A squared plus B squared. Or in my case, 1 squared equal to X squared plus X squared. That's really Pythagorean theorem used on this right triangle. Collect like terms. Divide by 2. Basic algebra here. Now, to a square root, it looks like this for the x. Can anyone tell me? I can't leave it like that. What does square root 1/2 look like cleaned up, simplified? Well, first, you could say this. I think I heard someone else give me the correct response. You could say, Professor, it's radical 1 over radical 2. You can do that, but you can't leave a radical in the denominator. It's called rationalizing. So you need to clean it up by multiplying by radical 2. So you're going to end up with radical 2 over radical 4 on the bottom, which is nearly 2. And there's your response. So my first coordinate is radical 2 over 2. That's the x. I just discovered what it is. What we left out here. The other side of the right triangle is also, since it's an isosceles triangle, it's the same number. We have two sides equal here. And therefore, this is also radical 2 over 2. For my coordinate. Does it make sense? So 45 degrees is radical 2 over 2, radical 2 over 2. That's what I'll accept. Now, I don't have the time to do as much. Nima, I'm going to now reflect this across the y-axis and take it into quadrant 2. If I do, much effort needed here, we'll make it something like this. Reasonable as I can. Make it more reasonable. Something like this. Oh, that looks better. And here goes. Guys, if I drop the perpendicular and do the business like I was doing before the break for the 30, I'm doing it for 45 this time. This is 45 here in the corner. Just reflected across the y-axis. Now, I know if I'm in quadrant 2, the coordinates are what, guys? Negative, positive? And the points in quadrant 2? So can you tell me, Nima, what on earth would be the coordinates of that terminal point for that particular angle? What should I list the coordinates as?
Negative square root of 2 over 2.
Negative radical 2 over 2. And?
Square root of 2
Got
over
it. Got it. Now to sort of close this down. That makes sense. Now, what size angle is that over there? That means from the initial side all the way over. And give it to me in degrees. Then we'll convert it to radians. Or you might know what it is in radians right now. So now I need the size of the angle that takes me from the initial counterclockwise all the way over and stops there. That's the angle I'm looking for an association. I mean, I'm going to use degrees. How many degrees is it? 135. It's 180 subtract 45 on my sketch. So 180 subtract 45 on the sketch, what? 135? And if you convert 135 by using a conversion factor, help me out, guys. It looks better in radians expressed as what? Anyone? 3 pi over 4. That's the side of the angle. And now I know its coordinates. So guys, just underneath there, so if you're asked to find this, there we go. Sine of, side here, more space. Sine of pi over 4, and sine's definition, I'll erase all the definitions, sine's definition is y. I said, Professor, the y coordinate here is radical 2 over 2. That's all they want. If you're asked to find, for an example, secant of pi over 4, and I've erased my definitions, that's 1 over x. Well, the x here for 45, or pi over 4, is radical 2 over 2. It's going to look a little messy, That's 1 over that. Now, without me going through too much detail, can someone tell me, I'm looking at myself, what do you think they'll simplify into? We got simplify. What word? I think it's just radical 2. Now let's see why though. This can be tricky. It's 1 divided by radical 2 over 2. That's what it says. Or 1 times, flip this over. Reciprocal. You can't leave that radical 2 there, so you can rationalize. Multiply by radical 2, radical 2. So you're going to end up with 2 radical 2 in the numerator, and a nice, just plain 2 on the denominator. That's radical 4 down there. It's 2. 2's cancel. So she is correct. It's radical 2. Now, before I leave it, here we go. I'd like to find now tangent, from here, of 3 pi over 4. I'll remind you what tangent was by definition. It's y over x. You gotta know your definitions. Guys, 3 pi over 4, that's one we just worked with here. The green here, I see the coordinates right next to it. If I place the y over the x, I'm placing radical 2 over 2. That's the y. Over the x, which is negative radical 2 over 2. I think that is merely negative 1. I think everything cancels. So that's tan of 3 pi over 4. Making sense the way we do it? Now, since I don't have time to do all the other quadrants, just I'll throw out a question and we'll move on. Anyone tell me, I've got some clever students. If I move down to quadrant 3, anyone first tell me what the coordinates, which these are the originals here. If I'm down in quadrant 3, they become what? Negative radical 2 over 2, negative radical 2 over 2, or negative, get out here. Anyone tell me with a 45-degree, I'm going to start calling it reference angle. With that 45-degree reference angle, move down into quadrant 3, anyone tell me what size angle is it by the time it gets down there?
225.
There we go.
225.
225. 180 plus 45. 225. Or in radians, 5 pi over 4. If I move on down into quadrant 4 to finish up this conversation, down here, I know this. These coordinates now become down here in quadrant 4, what, a positive and a negative for the coordinates. Can anyone tell me the size of the angle if I take that 45 reference into quadrant 4? Oh, 315, love it. 315, 315 degrees. Converted to radians, 7 pi over 4. Okay, so we know how to deal with that. Okay, guys? So just some special angles, 30, 45, 60, and I'll list all these for you probably tomorrow in a recap on all this. But today I want to show you where they came from that unit circle. Guys, any questions here? Anything at all? I've enjoyed this. Just to show you where some of those numbers came from on that unit circle. Now, with all that said though, let me jump down to, I got it down there. And, hang on just 1 second here. Get back down here. I need now to continue what we were doing before the break. With your help, can someone list, I have everything erased over there. Can someone list other properties, relationships among those trig functions? We started out with tan. Tan was y over x, better expressed as sine over cosine. Secant's definition was 1 over x, better expressed as 1 over secant. Can anyone come up with anything else?
Cosecant is 1 over sine.
Over to me again.
Cosecant is 1 over sine.
Love it, love it, love it, love it. Love it. Cosecant is 1 over sine. Need more. Oh, wait, I mean, something about cotangent, hang on. And what do you want for cotangent?
Cosine theta over sine theta.
Love it. I know this. Just the basic definitions written up. Let's call this letter E. Can someone come up with another one maybe at this point? Yes,
Sine squared plus cosine squared is 1.
Ray. Well, you came up with one I thought nobody would come up with. Sine squared plus cosine squared is 1. Look at this. This is one of the major ones. Ray, thank you so much. Now, in essence, someone tell me, what did she just express so beautifully for us? Sine squared plus cosine squared is equal to 1. That's saying what?
A squared plus B squared equals
Go tell me again.
A squared plus.
Pythagorean theorem sort of involved here. I'll take that, something else. She just said sine squared, professor, plus cosine squared, professor, should always give you 1. I'd like to know why.
Triangle A squared plus B squared equal to C squared.
Okay, I know, I heard that before. C squared is equal to A squared plus B squared, which I accept. That's Pythagorean theorem. Actually, that's what's said up here. Okay, let me ask you this. Throw it out there. I don't know whether on the handout, did they give a name to the unit circle besides just saying unit circle? Did they give a name for it, an equation for it? They didn't? They didn't give a name for it, an equation for it? Guess what you could use? I wish they had. You could use an equation that represents that circle. Look at this. Ray, I love what you said. Here we go. You might want to mark that on the handout. X squared plus y squared is equal to 1 is the equation for the unit circle. You take any point on that unit circle, square the x, square the y, add them up, you're going to get 1. I don't care what point you work with on that handout. Square the x, square the y, add them up, you're going to get a 1. So that can serve as the equation for a unit circle. That's what it is. Now with her beautiful help here, she says, Professor, I may have mine turned around backwards here. The way she gave it to me, I prefer what she gave it in that form. We'll turn it around backwards. Saying the same thing. She says, wait, Professor, y is sine, and x is cosine. So why not write this as she gave it to me, sine squared plus cosine squared is equal to 1. This is the same as saying y squared plus x squared is equal to 1, always. Great, you set me up, thank you. Now, I will now show you 2 more that maybe you don't know. I don't know about this class though. This class is something else. Someone may know. I was supposed to derive it for you and show you where it came from. Does anyone think they know another one? Ray, I'm pleased to hear that one. Nima.
We can use this formula and say sine squared equals 1 minus cosine squared.
We could. There's no problem with that. No, what's something a little bit more? Barbara.
Tangent plus cotangent equals
No, I want
second
something.
multiplied cosecant.
No, what you guys are saying is correct. It's not one of the ones we recognize as in all the textbooks. There's something else. And you may know it, but I'm going to derive it. I'm going to show you what it is and where it came from. Easily derived.
Tangent squared.
Hey,
Well, if you divide everything by sine squared, don't you get new
hang on.
values?
So you're saying go back to Ray's answer
Yeah.
and do this to it. You got to leave the black is there.
Yeah.
He says go back and do this. This. And he says now with that adjustment, you can now rewrite another, or write another property here. And guys, I think sine squared over sine squared is 1.
Tangent squared.
Yeah, 1. Plus, can anyone give me a good name for this one? This is cotangent squared, because cosine over sine was identified as what? Cotangent, so that's cotangent squared. Wow. And 1 over sine squared could be rewritten as, is it cosecant squared? And now you have another. Let me count them. 1, 2, 3, 4, 5, 6. I want to do one more.
Tangent squared plus 1 equals to.
Whoa, 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 whoa. Tangent squared plus 1 is equal to
Secant squared.
secant squared. Now let's see where that came from. Gotcha, you are correct. Now, he just gave me, let's go back to what Ray gave me. That's why I was so pleased with her answer, because I'm basing these others on her answer. She says, Professor, this has got to be true. Now, this time to modify it. Last time, I think, Aiden, you said divide everything by sine squared on Ray's answer. Now, suppose I divide everything by cosine squared on her answer. Ms. Ford? A little adjustment here, cosine squared. Cosine squared, watch carefully. Another name for sine squared over cosine squared is? Tangent squared. Sine over cosine is tan, so this is tan squared. And we got cosine squared over cosine squared, you know what that is, that's 1. Who thinks they know what 1 over cosine squared might be represented as? Secant squared. Now you have what they identify as the major properties to work with in trig. Throughout. I don't care if you go to another country and take this, it doesn't change. Isn't it? It's established. These are called properties. Your textbook, which I like, they give a name to it, they call them these statements identities. These are identities. Properties. In other words, identical. Phrase, doing a little different phrasing there on this. So guys, I'll accept that, and we'll sort of close down what I gotta do here shortly with those identities. And those are the basic ones that we need to work with. Thank you, thank you, thank you, thank you. Now, I'll do one more thing, then I gotta slow down and show a rational function. I think you guys will be quizzed tomorrow on rational functions. I'll show you one of those. Jonathan, you had a knockout problem. I gotta show the class that because I usually have it on the test. So on Friday, you'll probably see one like it. I gotta work it out. Some of you guys may have tried it, and we'll work it out. Mr. Parker, you guys working on that review?
Oh, we're fine.
Marina, you didn't tell me, did you show him you got the review for the test on Friday? You guys were gonna go down to the math lab and work out the answers, weren't you?
Yeah,
You're
I'll,
gonna give a sign that we can leave.
Yeah, you're gonna leave
Oh, we can leave?
right now. Go to the math lab. And then you're supposed to work them out, and it's gotta be neat, so things.
Yeah.
And I've already worked out, I gave you the page I've worked out myself. I worked out some of those. I gave you the
Yeah, here, I have.
So you guys okay now?
uh-huh.
Yay. I was talking to my nephew last night. You're worse than my nephew in med school. Going crazy. Okay, guys, go down to the math lab.
Professor.
Oh, you got, what's that? Oh, thank you,
Yeah.
thank you. This is something else. I'll tell you more about that. Okay, here we go. We'll accept these. Over here, we got that done. I'll save a little time here. And we'll close this down. Guys, have had a good night, though. Got a lot done here. Yeah, I have a nephew in med school. He's going to NYU and doing work there. So He's sort of going nuts. I ask him all the time, how are you enjoying New York? Aren't you crazy about New York? I don't get out much. I said, well, I don't hardly leave campus. Because he's in med school, he's trying to do this and that, he's changed his field quite a few times. Wanted to do this, wanted to be a dentist at first, no, now he wants to be, Botox and fillers. Yeah, he wants to do that now. I thought, who knows why he's gonna do that? I don't know. Anyway, he's gonna do something. Okay, guys, to close this down, I'm trying to use these properties. And then we're going to review some. I brought this in. Let's see if it's gonna work. Yeah. Given. A place to close this down. Let me give you some information. Sine theta is equal to 2/3. And comma, tan of theta is less than 0. Find the value of the remaining 6 trig functions. I'll just phrase it like this. Remaining trig functions. We're about to close down here, then we'll review a little bit. Let's step back and look at it. Beautiful. Find the value of the remaining trig functions. How many trig functions are there altogether? 6. I gave you sine. That means you gotta find cosine. Close this down. You gotta find tangent. Well, this next secant, next to what order these are listed as, secant's missing. Cosecant's missing. And I think cotangent's missing. Now this is gonna be fun. This is gonna be fun. Now I gave you 2/3. I said sine is equal to 2/3. You say, Professor, you said earlier sine's definition was y. Well, it is. Guarantee you, if you look at that unit circle on the handout, and you go through that unit circle on the handout and look at all they gave you there, you're not going to see a 2/3 for the y coordinate. It's not there. So that particular angle that does have a y to be equal to 2/3, there is one out there. It's not listed. It's not one of those special ones on the unit circle. So I cannot approach it by going to the unit circle. The unit circle's not going to help me out here. 2/3 is not there. Anyone tell me as I close down, what will help me? What do you think will help me?
Sine squared cosine squared is 1.
I had better go down here, John, thank you. I better go down here and pick up one of these. And apply it over here and see what happens. Okay, here we go. You're saying first, Jonathan, I can use this. And when I finally quiz you on this, exam or quiz, you gotta show me the identity or property you're using. He says, Professor, we're gonna use sine squared plus cosine squared is equal to 1, because you gave me sine, I can put that in there. Sine is 2/3, so put 2/3 right here. That's given to me, squared, plus this, watch carefully, equals 1. I gotta watch carefully my time here. Okay, this becomes, guys, my replacement, sine is 2/3, squared is 4/9. Plus cosine squared is equal to 1. We'll solve this like an equation. Let's move that 1 over by subtracting. Guys, when I move that 1 over, 1 subtract 4/9, what's left over? 5/9. Just basic arithmetic. Take the square root. Now, I would say at this point, if you do a square root, and I see a cosine squared, which indicates 2 answers, like a little white bracket gets it. It looks like it's plus minus square root 5 over 3. But I cannot accept both. There's only one answer. Right? There's only one answer. But right now, it's plus minus radical 5 over 3 for the answer. Which is it? Is it positive or negative? It all depends on this information. Now I gotta find which quadrant of the four quadrants am I located in. Then I can determine then what sign to use. For middle school. Guys, they give me sine to be 2/3, that's a positive. So the y is positive. Comma. They said also they want tangent, which is y over x, also to be, to be negative. Now, we gotta search the four quadrants and find, where is the y positive? But the tangent, y over x, in that same quadrant, is a negative. Is it quadrant 1, quadrant 2, quadrant 3, quadrant 4? Where is it?
Quadrant 2.
Okay, I'm hearing it. Here we go, guys. I'm hearing quadrant 2. Let me label this. Just to make sure. Okay, let's check out quadrant 2. Sine is sine, which is y. Is that sure enough positive in quadrant 2? So sine is positive here. Right like that. Is tangent, which is y over x. When you place the y over the x in quadrant 2, and by the way, if you're in quadrant 2, guys, the coordinates are those. If you place y over x, which is tangent, you sure enough end up with a negative. A positive over a negative. So is tan negative also in quadrant 2? Yes or no? Tan is negative in quadrant 2. Is that what they wanted? They wanted sine to be positive, positive 2/3 in this case. At the same time, tan is negative. Do those two work out in quadrant 2? So now I know I'm in quadrant 2. I'm doing cosine. Cosine is the x. If I'm in quadrant 2, well, please tell me, what should I accept? Is it positive or negative for cosine, which is x, if I'm in quadrant 2? Negative. I gotta erase this positive sign. Final answer is negative radical 5 over 3. Wow. Yes or no? Making sense? So we now have established with some help, I'm in quadrant 2 for all these answers. Tangent. Now they want tangent. But tangent's definition was y over x. Or, better yet, can I use one of these down here? It's sine over cosine. If I have both, do I have sine and cosine listed up here? If so, I can just place sine over cosine. Sine was given to me. Cosine we just discovered. Why not? So on the side here, I'm going to use tangent. Now the identity, property, is sine over cosine. We've done a lot of work tonight. Guys, so I place sine, which they gave me as 2/3. Put it right here for you so you can see it. 2/3 with sine. Cosine, we're hoping, is that answer there? Negative radical 5 over 3. That's sine over cosine. 3's will cancel. Rationalize. Can someone tell me what that looks like all cleaned up and simplified? 3's will cancel. Does anyone know what that looks like simplified? I'm hearing something negative for sure. Negative what?
2 radical 5 over 5.
2 radical 5 of here over what?
5.
Over 5. That goes here. There's another value. Done. Now secant. Well, secant's original definition was 1 over x, but can I find, to support it, one of these to turn to get the answer? That says I want secant. Could I use 1 over cosine? And secant says 1 over cosine, which is saying 1 over x. So guys, I'm putting it in red right here to show you which one I'm using. Secant is equal to 1 over cosine. I know all this. That's 1 over cosine. Let me do it like this for you. That would be 1 over, and cosine is this answer, which we're hoping is correct. Negative radical 5 over 3. I'm running out of space there. This will be a negative answer. Can anyone tell me what this right here, simplified, looks like? It's tough.
Negative 3 radical 5 over 5.
Wow. Wow. That's it. Negative 3 radical 5 over 5. And I have the supporting red there to support which property I'm using. Cosecant, to find cosecant, if I want to use a property, guys, I could try 1 over sine. So cosecant should be equal to 1 over sine. There it goes. I'm running out of space on this side, put it over here. So cosecant by property is 1 over sine. Or that's equal to, in this case, oh, this was a little bit easier because it's 1 over, and they gave sine to me. It's 2/3. We all know that's 3 halves. That answer is done. Last one is cotangent. I don't know which one you want to turn to. I'm going to try if I can this one. Put the cosine over the sine, if that will work. Okay, put it up here, guys, in my house, please. Cotangent is equal to cosine over sine, which in this case is that negative radical 3 over negative radical 5 over 3 over 2/3 sine. Let's step back to look at it. Looks good. These cancel. So it's merely negative radical 5 over 2, if I have a mistake. You guys accept those answers?
Yeah.
Okay? And those are the answers. Navia, we're not going to see that on the unit circle. You have that handout, we all have that handout, we stare and stare and stare. You're not going to see numbers like that. They're not there. Now, I'm not going to do this, I'm stopping. I'm just out of curiosity. They're saying theta. Theta. I used, when I first started class at 3 o'clock, I used theta to be like 30 degrees. I told you what size it was. And I mentioned theta's 45. And then we did like theta was 210 or 225. 80. Myself, I have no clue. But there's an angle out there they're talking about here. There's an angle out there whose sine theta is equal to 2/3. I have no clue myself, unless I went to a calculator. And all these others, this theta is consistent all the way down. I'd like to know the size of it, but I could not find it unless I turned to a device of some sort to find it. That's it, I'm ready to close down here. Beautiful. Amy, tell the class. They gave me the sine of the angle, which is unknown. Not 30, not 45, not 75, it's unknown. I don't know myself. It's there. The sine, which is y, is positive 2/3. And the tangent, which is y over x, is what? Negative. We found it, I think we determined we're in quadrant 3, didn't we? Did we finally say the angle's in quadrant 3, or was that something else? Or was it, oh, sorry, quadrant 2. It's in quadrant 2. Now, I do know now, if I'm in quadrant 2, the angle must fall between what? 90 and 180. There's lots of angles between 90 and 180. But I know where it is. It's in quadrant 2. It's caught between 90 and 180. I have no clue what it is. If Mr. Park was here, he could go through and find it for us. Okay, guys? I think we've had enough trig today. You guys who are a little concerned, I think I've done 5-1, 5-2, and I think I touched upon 5-3. We did it. Now, am I done? No. Now, my students have asked, Professor, could you please, we got a quiz mark, could you please work out a rational function for us? Not the transformation, Professor, I'm more concerned about the rational function. We have to run through all those steps, okay? You want to see one worked out for practice? Right? Okay. That's enough time to do one. And, I do want, Jonathan, I do want to look at that problem you were asking about. The little time I have here. Beautiful day today, jeez. Okay, I brought one in. Oh, yeah, I brought one in, of course. Oh, boy. Darn it. Hang on. If I work this one out and it's all of a sudden it's a quiz problem, wouldn't it be something? Would you guys appreciate that? That's what I'm afraid I'm gonna do here. I can't find it, guys. Whoa, 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 whoa. I got it. This is not the one for quiz. This is just practice. Okay, the rational function, here we go. R of X is given to me as a ratio. Just going to reflect this. Oh, this is a nice practice. And I'm going to sketch it. Mr. Stevenson, remember you read all those little pieces to us? Do you still have that handout right there available up to you or not? You don't have it? Okay, I'll remember the best I can what all those parts, those parts will be typed up for you on the quiz. I'll have all those parts I want. Guys, first I'm gonna clean this up. I'm gonna factor 3x here, common factor, and I think the denominator will factor into that. That makes it look better. Now, I think the first thing that I'll have typed up on the quiz is, what is this function's domain? In its raw form, right now. X cannot be equal to 3 or a negative 2. So I said. By the way, if you should have canceled something, you saw something that we canceled, you still have to identify that as part of your domain before you cancel. That's what the handout says. Number 2, simplified, I did. We're right, we simplified it. Over this. Beautiful. Number 3, if I'm not mistaken, when you read that to us, I think I was asking now to find the intercepts. Let's find the x-intercept. Could be more than one. And let's find the y-intercept over here. This is going to help you. X-intercept, how do you find it? You replace y, r of x, by 0. And guys, if you want to go to the simplified version, you could, or it's already factored, or you could go back to the beginning. It's up to you. I'm going to try that simplified version. Step 2. Let's see if that will help me. That's where you find the x-intercept, set that equals 0. I would suggest you cross multiply quickly, which will take you down to this in no time. This, and then this, cross multiplication. And quickly guys, you split this up, I see one of the x's is 0, the other one is going to be a negative 4. Those are my x-intercepts. I'll write these as ordered pairs. One of my students in one class, not too long ago, asked me, Professor, if you're asking for an x-intercept on the rational function, is it merely each time just setting the numerator equal to 0? It is. If you want to think of it like that, just set the numerator equal to 0. That'll give you the x-intercept. Y-intercept, a little bit easier to find. You're supposed to find r at 0. In other words, replace all the x's by 0. Guys, if I replace all the x's by 0, please save me a little time here. You're going to end up with 0. And this is your ordered pair. You get all this partial credit for this. Number 4, I think, when he read this to us, they were asking for the vertical asymptotes, if any. Does anyone recall how you find them, if they are? If they exist? Anyone remember how to find them, the vertical asymptotes?
Denominator
He said
equals
the denominator equals 0 and solve. So you take this. This is going to be cute. Solve, you're going to get a 3. You're going to get a -2. Tons of partial credit here. Let's see, number 5. Let's finish this up. Horizontal. Now, you're hoping that tomorrow, because I have not mentioned the oblique, you don't have to worry about oblique. So you're hoping tomorrow, Professor, please keep this consistent with what you've already presented to us. And that is, Miriam, I'm hoping that we check out the degree in the numerator, the highest exponent, and the degree in the denominator, highest exponent, they're the same number. That's the best case ever. Why? Without going through too much thought, the horizontal asymptote will be merely this coefficient over this coefficient. So in no time, my horizontal asymptote, I'm going to put a y there, y is equal to 3. Okay? No problem. If those coefficients work out for me. Now, I should ask myself before I leave this and almost get to my graph and get this finished, is there a crossover point? My graph cross over the horizontal asymptote. Sometimes they do, sometimes they don't. So right here, guys, I'm looking for this. Is there a crossover point? Now, can someone tell me how would I find if when I draw that horizontal line and then draw my graph, are they going to intersect somewhere? How do I find it if they do? No.
He said it equal to 3.
Yeah, you got to set the horizontal asymptote, which is 3, equal to your function. And guys, you're going to use the original, go for it, which is 3x squared plus 12x. All over x squared, subtract x, subtract 6, looks messy. That's what you do, you set the horizontal 3 equal to the function, and see if they have something in common. We'll do a quick cross multiplication. You end up with 3x squared minus 3x, subtract 18, and in the other direction, 3x squared plus 12x is merely doing that. Cross multiplication. And you're going to solve that. The 3x squared drop out. This is nice. Guys, I can solve it. I'll end up with a -18. This is algebra 1 now. 15x. Divide by 15, reduce it down, that's a -18 over 15. Divide by 3, I guess. -6 over 5, how cute. I have a crossover point. Where is it? It's -6/5. That's the x. And of course the y, I'll do it like that, y is 3. That's my crossover point. Aiden, I think when Mr. Stevenson read this to us, he mentioned there could be a hole on the graph. Now, when does that happen, if it does happen?
When you cancel.
Thank you. When a factor cancels out, and back here, I did not cancel anything out from top to bottom. So there's no hole on the graph here. What else? Should I be worried about anything else? Is that it? I think that's it. Let's graph it. I think I have enough information to graph it. Good.
That makes sense.
Nice. Does it make sense?
Yeah, so I was looking at it as a, never mind.
Now, it's been a long time since you guys have seen one of these. So I'm glad I had time to do this. So here goes. Let's put all this business together. If you want to go back to the x-intercept and get those out of the way first, go for it. I got 0, where am I? -4, was it? Okay, so let's go to a -4. And 0, 0. My x-intercept, my y-intercept is also 0, 0. Marked it already. Vertical, got 2 verticals out of 3. Mark those, and I'll get out of your way here. And also -2. And it looks like this, just quickly. This. And this. Got those out of the way. Horizontal, yeah, there's a